This is some practice on some weather basics, reading a weather map. Obviously, these weather maps are a little bit more complex than you see on the weather forecasts on the news, but we are talking about how to figure out the information from these station models. And so having your weather slides, this one in particular, will be helpful. So you guys, you won't see me writing down the answers because you'll need to type in your own answers down here, but we're going to talk you guys through what the answers should probably be. So just kind of listen, follow along, pause when you need to, and write in your responses. So the first question is, according to this map, how will the weather in Phoenix, Arizona change in the next 24 hours, and how do you know? All right, this station model right here is Phoenix, Arizona. And I'm asking you, how is the weather going to change there in the next 24 hours? Well, it is going to change because this cold front sitting right here, the spikes show you that it's moving in this direction. So in the next several hours, Phoenix is going to experience a cold front, which is going to mean a decrease in temperatures because this air back here behind the front is colder than the air in Phoenix currently. Okay? So how's the weather going to change? The weather's going to get colder. How do you know? Because there is a cold front approaching. Okay? So that is the answer to question number 1. There's 2 parts, so make sure you answer both parts. Again, pause if you need to. Number 2, there is a low pressure center in which 2 states in the central United States? Okay, a low pressure center is marked with a red L. And here's one, and here's the other. So if I leave Texas and I go north, I go from Texas to Oklahoma, and next is Kansas. So there is a low pressure center sitting in Kansas. North of that is Nebraska. Keep going, and this is South Dakota. So there's also a low pressure center in South Dakota. So there are your 2 answers. If I had asked you about high pressure, then I would be looking for blue H's, which there's not a whole heck of a lot of. There's some that are kind of off the screen a little bit. Like there's one. Okay? But low pressure centers are marked with red L's. Number 3 says to describe the weather information for San Antonio, Texas. Use the information from the station model slide if you need to. Okay? San Antonio, Texas is this station model right here. Okay? And there are several pieces of information that I can find using this depiction if I know what I'm looking for. So let's go back to the weather basics slide. Okay? The circle marks the spot, whatever city it is, and then in the circle, you're going to color it in based on how much cloud cover there is. Okay, so let's look at cloud cover. Okay, so there's an isobar that's actually running right through San Antonio, so it's a little bit hard to see, but it looks like about 1/4 of the circle is colored in. So I would say partly cloudy, 25% cloudy, something like that. Okay. The next thing is to talk about wind speed and wind direction. The stick points into the wind. So for instance, here on the station model, the wind was coming from the north-northwest into the station. Let's look at what the wind is doing in San Antonio. The wind is coming from this direction into the station. Okay? So straight down would be south, straight to the left would be west. So this is probably south-southwest because it's more south than west, but not perfectly. So the winds are out of the south-southwest, and you can just put SSW. And then we need to look at how fast the wind is blowing. We have a little full bar and a half bar, a full flag and a half flag. A full flag is 10 and a half flag is 5. And it's in knots, but we fudge a little bit and we just say miles per hour, even though it's not exactly equal to that. So the winds are out of the south-southwest at 15 knots, 15 miles an hour. Okay. The next couple of things are these numbers, here, here, and here. Let's start with the easiest one. Temperature is your air temperature. It's always to the upper left of your station circle. So here's my station circle right here. To the upper left is 80. So I know that the air temperature is 80 degrees in San Antonio. To the lower left of the station circle is my dew point temperature. We haven't said a lot about dew point temperature, but dew point temperature gives us an idea of how much humidity there is in the air. Okay, when the dew point temperature and the air temperature are very close, like in this example in the station model, then the humidity is very, very high. There's a lot of water vapor. When those two numbers are far apart, then the humidity is low. So dew point gives us an idea of the humidity of the air. Okay. Now, this one, again, that isobar is running over some of our data, but that is a 68. So the dew point is 68 in San Antonio. And then we have one more number over here to deal with, and it says 038. That is going to tell us our barometric pressure, but it doesn't just get written down as 038 because there's some digits missing. So the first step for you to write down your air pressure for San Antonio, which I do want you to write on your answer, the first step is to put your decimal back in. The decimal goes between the 3 and the 8. So now you have 03.8. All right. Well, then you also need to decide what goes out here. You have to guess. Is it a 9 or is it a 10? Oh, Miss Goff, how do I know? Well, your normal air pressure readings need to be between 950 and 1050. So if I put a 9 right here, 903.8 is not in the 950 to 1050 range. 903.8 is too small. So I know it's not a 9. My other option is to put a 10. If I put a 10, that's 1003.8, 1003.8, and that makes sense. That's in the range that I want it to be in. So my barometric pressure for San Antonio is 1003.8. Okay? So you've had pressure, air temperature, dew point, cloud cover, wind speed, and wind direction. And those all go in number 3. All right, number 4 asks about the air pressure reading in Odessa, Texas. This is the station model for Odessa. Notice that in Odessa, it's clear. The skies are clear, but it's windy. It's blowing at about 30 knots, coming out of the west-southwest, mostly west, a little bit to the south. 981 is the number that we will deal with for pressure. It's 82 degrees Fahrenheit, and it is 36 for the dew point. 82 and 36 are really, really far apart, so we know it's dry out there. Okay? All right, but that's not what I'm asking you about. I'm asking you about pressure. So you take the 981 and you put the decimal back in. So now you have 98.1. And then do I guess a 9 or do I guess a 10 over here? If I put a 9, then it's 998.1. And that would fit in the 950 to 1050 range. If I put a 10, that's too much. Okay, so I know it's 998.1. There's your barometric pressure. So the first way you can figure out the pressure for Odessa is to take the pressure reading and do the steps. Put the decimal back in and put a 9. The other way that you can figure up the approximate air pressure of Odessa is by looking at your isobars, these blue lines. Okay, if you follow them around, this blue line says 1,000. This next blue line right here says 996. The one above it says 992. This one says 988, even though it's kind of jumbled up and hard to read. But Odessa sits between the line that marks 996 and the line that marks 1,000 millibars. So we know that Odessa's air pressure has to be more than 996 millibars, but less than 1,000. And so 998 is a decent guess because it's kind of sitting right between them. Okay? So your two ways that you can tell me the air pressure is by, number one, reading the number on the station model. But the other way you can tell me air pressure is by estimating based on the isobars that are drawn. Okay? So that's your answer for number 4. Number 5 asks what kind of front is sitting over the Great Lakes. The Great Lakes is this area. Okay, that is a stationary front. A stationary front means that it's a boundary line between two different air masses, but it's not moving. There's warmer air down here, there's cooler air up here, but neither air mass is moving. If the cool air begins to move south, then this is no longer a stationary front, it would be a cold front. If this air down here starts to move north, then this boundary is no longer a stationary front, it would be a warm front. Okay? So it's only a stationary front as long as it's not moving. And then last but not least, number 6, what are the blue lines on the map called? Well, the blue lines on the map are called isobars. On this particular map, from one isobar to the next is a difference of 4 millibars. Millibars is just your unit for air pressure, which is actually the answer for the other part of the question. What do the blue lines tell you? They tell you air pressure. Okay? So this line actually connects locations that are all the same air pressure. Everything along that line has an air pressure of 1,004. Everything along this line has an air pressure of 1,000, etc. Okay? So I hope that helps you guys out and walks you through it, because the daily check-in for the following day is going to be more practice on this. All right.